मित्रांनो सगळ्यांनी अटेंडन्स सबमिट केला का?
हो सर.
Okay, okay. Okay, friends, good morning to all. We are going to start the today's lecture. Here I am saving your attendance in chat box. I can share the screen. Yes, screen is shared. Uh, yes, screen is shared. Aishwarya.
हो सर.
Okay, screen is visible well. Okay. In last lecture, we came to here, that is the different energy form resulting from the solar energy. And today we are going to start, that is the solar energy spectrum, that is the whole, right? The total solar energy spectrum in which the ultraviolet rays, visible rays, and infrared rays are present. Uh, it is the variation of the solar energy flux with the wavelength of the radiation. It means that spectrum is depend upon the frequency. It will be depend upon the wavelength. We know you know that the wavelength is related with the frequency. Then solar energy flux received from the sun outside the earth atmosphere is the constant. We know that outside the earth it is the constant. Okay, however the spectral distribution of the energy flux outside the earth atmosphere is called as the solar spectrum. Solar spectrum is the description of the solar ray outside the atmosphere. It will be known as a solar energy spectrum, and that spectrum in detail it is shown in following diagram. I am going to see you the diagram in just a while. Then that solar spectrum, this is the diagram. That solar spectrum is the variation of the solar energy flux. It is the variation, means the solar energy is the contamination of the different radiation. It is contamination of the different wavelength. It is made of the different wavelength as well as the frequency, and all that description of that all frequencies and wavelength, that will be known as the spectrum. The solar spectrum is the variation of the solar energy spectrum with the wavelength of the radiations. If the wavelength of the radiation, there are some mistakes in the spell. These radiations receive outside the Earth atmosphere as expressed in terms of the solar constant. We are going to see the solar constant, solar insolation factor, as well as the solar clarity. These are the three different constants which are very essential to plan the uh, solar energy conversion plant. Solar energy conversion plant. There will be these three characteristic, or these three constant are very essential, and according to that constant one can able to design, able to form an solar plant at any place and any location. Okay, that is the solar constant is the very one essential. If the solar constant is the larger, then one can able to plant the solar energy plant on that place. Okay, because these three physical quantities along with the solar energy or the solar radiation are very essential. That is the solar constant, solar clarity, and solar insolation factor. Okay, the solar constant is the rate at which the energy received per unit area normal to the rays of the sun at the moon distance of the earth from the sun. Means just we have to go in between the sun and earth. We have to go at the midline or the midpoint in between the sun and earth. That is the distance of the moon, where the moon is present. In between earth, sun, moon is present, and at the distance of the moon we have to calculate the solar constant, and the solar constant is the rate at which the energy received per unit area normal to the rays. That is the rays normal to the rays, and that the energy received per unit area, that will be known as an solar constant. And solar constant is measured in at the moon distance, friends. At the moon distance, the earth rotate around it sun in elliptical orbit, and whereas the very small eccentricity e in the ellipse, in the ellipse where e is less when the eccentricity and the sun is at the one of the foci, and due to this, the distance between the earth and sun varies slightly throughout the year. We know that the e eccentricity factor is not same over the ellipse, but it is same over the circle, that will be known as an radius. Okay, but it means that as eccentricity factor is changes, the solar constant is changed, and that solar constant changing its eccentricity factor according to which the solar constant is depend. Hence the extraterrestrial energy flux is also varies, and this variation is about the plus minus 3.3%. 3.3%. See here, this is the solar spectrum. Just I am reducing this diagram to see in at a glance. Yes. Okay. See here, डायग्राम दिसते आपल्याला सगळ्यांना. ओके. स्पेक्ट्रल एक्स्ट्रॅटिशियल रेडिएशन हे रेडिएशन्स आहेत वाय ऍक्सिस वर, आणि एक्स ऍक्सिस वर मात्र आपल्याला काय दाखवलेलं आहे, वेव्हलेंथ दाखवलेली आहे. दॅट इज द वेव्हलेंथ. दिस इज द वेव्हलेंथ. वेव्हलेंथ मीन्स द 0.3 म्हणजे 3000, 4000, 8000, 12000, 16000 आणि 20000 एमस्ट्रॉंग युनिट मध्ये आहे. इथं दाखवताना इथं मायक्रोमीटर्स मध्ये दाखवलंय. मायक्रोमीटर्स म्हणून ते 0.3. 0.3 मीन्स इट इज इंटू 10 रेस टू पॉइंट मायक्रोमीटर आहे इंटू 10 रेस टू 3 आहे. इथं आपल्याला मीटर्स मध्ये येईल, आणि पुढे जाऊन कन्व्हर्शन त्याचं एमस्ट्रॉंग युनिट मध्ये आपल्याला करता येईल. म्हणजे 0.3 म्हणजे आसपास 3000च्या आसपास आहे मित्रांनो. पुन्हा 4000 ते 8000च्या आसपास विजिबल दिसतोय बघा, आणि 8000 ऑनवर्ड इन्फ्रारेड दिसतोय. हा 3000 ते 4000 अल्ट्राव्हायलट दिसतो. अल्ट्राव्हायलट, सियर आय एम टेकिंग दी एनोटेट. अल्ट्राव्हायलट इज सीन इन 3000 ते 4000 एमस्ट्रॉंग युनिट वेव्हलेंथ. पुन्हा 4000 ते 8000 मध्ये आपल्याला दिसतो विजिबल, आणि अबाव दी 8000 आपल्याला दिसतो इन्फ्रारेड. याच्यामध्ये जर इथं जर आपण त्याची इंटेन्सिटी बघितला, त्याचे रेडिएशनची इंटेन्सिटी बघितला, तर इथं 500 आहे. फ्लक्स म्हटलंय त्याला. इथं 500 वेबर पर मीटर स्क्वेअर मीन्स एम एम मध्ये आहे. पुन्हा 1000, 1500 ही वाढत जाते. आणि आपल्याला जर बारकाईनं बघितलं, तर विजिबल रेंज मध्येच त्याची इंटेन्सिटी काय आहे, हाय आहे. अल्ट्राव्हायलेट रेंज मध्ये त्याची इंटेन्सिटी कमी आहे, आणि इन्फ्रारेड मध्ये सुद्धा त्याची इंटेन्सिटी कमी आहे. आपल्याला काय दिसतंय बघा, हा जो फर्स्ट इथे एक डॉटेड आपल्याला एक कर्व दिसतोय, आणि डॉटेड कर्व जो आहे, हा डॉटेड कर्व आहे तो सोलार इन्सुलेशन कर्व आहे. दॅट इज द कर्व नंबर 2 असं म्हटलेलं आहे याला. कर्व नंबर 2. कर्व नंबर फर्स्ट ला एक्स्ट्रा टेरिटिशियल रेडिएशन असं म्हटलंय. एक्स्ट्रा टेरिटिशियल रेडिएशन बाहेरच्या वरच्या वातावरणामध्ये. सोलार इन्सुलेशन म्हणजे पृथ्वीच्या जवळ नियर दी सरफेस ऑफ दी सरफेस ऑफ दी अर्थ आहे. म्हणजे नियर दी सरफेस ऑफ दी अर्थ जवळ आपल्याला मिळतो ती, दॅट इज दी कर्व सेकंड, दॅट इज द सोलार इन्सुलेशन, दॅट विल बी दी ग्राउंड. दी सेकंड कर्व, दिस इज दिस कर्व, जो आपल्याला झिगझॅग कर्व दिसतोय बघा, झिगझॅग कर्व दिसतोय, दॅट विल बी दी कर्व फर्स्ट. झिगझॅग कर्व दिसतोय हा. हा एक डॉटेड झाला, डॉटेडच्या वरचा झिगझॅग कर्व आहे तो एक्स्ट्रा टेरिटिशियल रेडिएशन. अगदी आपण एक्स्ट्रा टेरिटिशियल मध्ये जाणार, अबव द ऍटमॉस्फिअर जाणार, तिथं मिळणार. आणि हे जे आहेत ऍट द ब्लॅक बॉडी रेडिएशन स्पेक्ट्रम, हा तिसरा आपल्याला दिसतो तो ब्लॅक बॉडी रेडिएशन स्पेक्ट्रम आहे. जवळजवळ एकसारखेच सगळे दिसत आहेत. कर्व सेकंड आणि कर्व फर्स्ट हे झिगझॅग कर्व आहेत. कर्व सेकंड जो आहे ब्लॅक बॉडी कर्व जो आहे तो झिगझॅग नाही आहे, तो स्मूथ कर्व आहे. म्हणजे कर्व थर्ड जो आहे तो स्मूथ कर्व आहे. कर्व फर्स्ट आणि कर्व सेकंड जो आहे तो कर्व जो आहे तो झिगझॅग कर्व आहे. इथं वेव्हलेंथ आपल्याला दिसते. बाकीच्या सगळ्या गोष्टी या स्पेक्ट्रम मध्ये किंवा या फ्लक्स मध्ये आपल्याला क्लिअर दिसत आहेत मित्रांनो. आणि टोटल सूर्याची जी एनर्जी आहे दॅट इज द सोलार रेडिएशन आहे ते आपण कसं डिस्ट्रीब्यूट करतो. दॅट इज द डिस्ट्रीब्युशन ऑफ द सोलार रेडिएशन इज टू बी seen in this diagram or in this graphical representation. In this representation, the dotted curve will be the interstitial curve that will be seen in at the above the atmosphere. The second curve is the extraterrestrial radiation. Extraterrestrial radiation. Sorry, the first curve is extraterrestrial. Second curve is on the surface, that is solar insolation on ground आहे बघा तो. And third one is the black body radiation. Just we are going to see this explanation from this. What is that? This is the spectral distribution of the solar radiation outside the Earth atmosphere, and the silent feature of the solar spectrum is as below. Some silent features are to be seen from this graphical representation. One, the solar energy spectrum mainly consists of the three part set. One is the ultraviolet, whose range is below the 3000 to the 4000 Armstrong unit. Second is the visible that will be able to seen, that will be recognized by the human being eye, and that range is, we know that that range is from 400 to the about the 750 or 760 Armstrong unit. That is the zero point 0.4 micrometer to the 0.76 micrometer. That is the longest visible ray. Red is the highest, and after the ray the laser is to be started, and that will be goes to the infrared. And the third region is the near the infrared means that which produces, that which gives, or that which affects the heat, that will be the infrared. And infrared radiation whose wavelength is varies from the 0.76 amps micrometer to the 1000 pm, that is very very high. And these radiation are the ultraviolet. First is the ultraviolet, second is the visible, and third is the infrared. Ultraviolet, these are producing the some poisoning effects. The visible not produces any effect. They will be visible. They will be used to see by the human being. And third one is the infrared. Infrared is the which can produces the heating effect or the radiation effect here. The second is the most of the solar energy is available in the visible region. जर आपण बारकाईनं बघितला तो कर्व, त्या कर्व मध्ये मॅक्सिमम जी इंटेन्सिटी ऑफ द लाईट दिसते ती फक्त व्हिजिबल मध्ये दिसते. म्हणजे जर आपण बघितलं सोलार रेडिएशनचं जर डिस्ट्रीब्युशन बघितलं, फ्लक्स बघितलं, तर जास्तीत जास्त सोलार एनर्जी ही आपल्याला कुठल्या फ्रिक्वेन्सी मध्ये दिसते? व्हिजिबल फ्रिक्वेन्सी मध्ये दिसते. That is the most of the solar energy is available in the visible region, and maximum energy flux is the wavelength is the 0.5, that is the yellow, that is the 0.5 हे त्याची मॅक्सिमम काय आहे फ्रिक्वेन्सी आहे. From diagram 2.2 it is seen that the solar energy flux first increases sharply increases maximum होते आणि पुन्हा डिक्रीज होते. अगदी हिल लाईक रिजन आहे बघा, अगदी टेकडासारखं आहे. सुरुवातीला वाढत जातं, मॅक्सिमम होतं आणि पण हळूहळू 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 कमी 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 होत जाते. दॅट इज द थर्ड. About 95% of the solar radiation are present in the wavelength between 3 to 2, आणि 50% रेडिएशन अप टू 0.76. म्हणजे जास्तीत जास्त एनर्जी जी आहे ती 3 to 2 to 3 मध्ये आपल्याला मिळते. म्हणजे 2000 ते 3000 मध्ये मिळते. The radiation spectrum shows that 2.2, that is curve 1, is almost a black body radiation. Curve HI, that is the curve 3, and it can be not HI, this is the curve 3, friends, this is the curve 3. Solar radiations are to be kept, that will be shown in the second region, that is the second curve. And the area under the first curve are the dimensions of the Weber per meter square, and it represents extraterrestrial density, and known that the solar density, solar radiation intensity, and that will be the constant at the solar constant 8. The area under the curve second is the solar power density. Solar power density, area under first is the solar radiation density, that is the it is used to calculate the solar constant. The area under second is the solar power density, and the second curve second shows here, here the curve